This question has to do with generators. And the question is, let's write a generator function called readN that'll take two arguments, a file name and a number, which we'll call n. And with each iteration, the generator should return n lines from the file. And if there aren't n lines remaining, that should return as many lines as possible. And I guess it goes without saying that at the end of the file, we should stop the iteration altogether. So there are a few different parts to this. Let's first start off with the fact that when I read from a file, when I iterate over a file, I should say, I'm going to get each line of the file one at a time. So if I say for one line in open, that's the password, then we're going to say print one line, and sure enough, we get each line from the file. And that's not because I've used the variable name one line here, it's because the iteration protocol, which for is using, is turning to the file object, is turning to the opened Etsy password file, and saying, give me your next, give me your next, give me your next, and with each next iteration, we're going to get one line back. But there are many types of files that don't lend themselves to this kind of reading. Instead of reading one line at a time, we might want to read 2 lines, or 5 lines, or 10 lines at a time. So how can we do that? Well, we're going to need something that will fit into the iteration protocol, right? I'm going to want to say here, read n, let's say call it 5, and I'm going to say here, read one chunk. And so my goal is to be able to say, I want to read one chunk at a time, and each chunk will have either 5 lines, or if we're at the end of the file, it'll have sort of whatever remains there, and then we'll end. So readN looks like a function. It looks like a function, but it's going to have to return something that knows how to work with the iteration protocol in Python. And that's what we call a generator function. A generator function looks just like a regular function, except that it doesn't use the return statement, it uses the yield statement. And yield says to Python, return this value to my caller, but the function should not go away entirely. Rather, the function should sort of go to sleep. And when we next ask for the next value, then the generator should continue running from wherever it left off. Here's the simplest version of readN we can write, which is not going to do what we want, but it'll be a good start. So I can say here, def readN. I'll take here file name and n. And I'm just going to do this. I'm going to say here for one line in open file name, yield one line. This is not at all what we want. This is just going to return one line at a time. And indeed, we get exactly the same result as before, because readN, when we call readN, we're going to get back this generator object, which implements the iteration protocol. And then we're going to go over it one at a time. Basically, each time for asks for the next from readN, it executes the function up to and including our yield. Yield returns something, falls asleep here, and then we come back to it and it continues running through the next iteration until we get to the end of the file. Well, there is another way I could do this, of course. I don't need to be quite so tight with my for loop. I can say here f equals open file name. And then I can do something like this. I can say here one line equals f read line. And then I can, now, how is that different? Well, readLine is a method that reads one line from a file object, up to and including the next new line, just like we would get from iterating over it with a for loop. But then I can do something like this. I can say here, if one line, yield one line. Else, well, else what? Well, I'm only doing this once, it would seem. So really, I'm going to need to do this again and again. While true. Here's an infinite loop. And I'm going to say, in this infinite loop, we're going to keep reading lines from the file. If there's a line that we got, if basically this means if we did not get the empty string, if we didn't get an empty string, then we're going to yield whatever we got. But if we did get the empty string, we're going to break. What are we going to break out of the while loop? When we break out of the while loop, we exit from our readN. And once again, we've gotten exactly the same results as before. So what have I done? I've made this longer and a bit more complicated, but I haven't really accomplished what we want. Because so far we've been ignoring n completely. So what do I want to do? I don't really want to read one line. I want to read one chunk, right? So we can say here one chunk. And one chunk here we can say is fReadLine, but that's not really what we want. What we want to do is run fReadLine n times. And this is a perfect opportunity for us to use a list comprehension or even a generator expression. And so what I can do is I can say here fReadLine for I in range n. Well, that's going to return a generator, right? So what I'm going to have to do here is say, we can just say empty string join on this thing. I don't need the double parentheses there. So what's going to happen here? What's going to happen is, while true, we are going to read n lines from the file using f.readline. F.readline will either return the current line, that's say the upcoming line, up to including the next new line, or it will return an empty string. We're then going to take all the things that we got back here, and we're going to stick them into join, and join is going to give us one string based on that. And that's going to be our one chunk, either n lines, or slightly fewer than n lines if we reach the end of the file, or an empty string if we're already at the end of the file. Meaning that what's going to happen now is we are indeed going to get our chunks. And we can see that I got here 1, 2, 3, 4, 5 lines, and then 1, 2, 3, 4, 5 lines, and then 1, 2, 3, 4, 5 lines. And if I change this to be, let's say, 3, my chunks are going to be instead, my computer's still thinking about this. This didn't quite wake up today. Let's just interrupt this and try this again. There we go. And now you see that I have 3 lines, 3 lines, 3 lines. So indeed, we've managed to do this. We have managed to pull this off. So writing a generator feels a lot like we're running a function. The difference is that yield says return this value, and the stack frame, the information that the function has accumulated until now within this run of the function, sticks around. So all of our local variables are still there. Our iteration is still in the same place. We don't need to keep track of this across calls because Python is doing that for us. And so this is one way that we can run a generator. Now, I just want to add one thing. Could we have returned a list of chunks from the file? Absolutely, we could have. But consider if it's a really, really big file, then we're returning a list that's huge, potentially huge. A generator, by contrast, because it's just reading one chunk at a time, returning one chunk at a time, and it's only reading one line at a time from the file, the maximum memory it's really going to use, besides the generator overhead itself, is going to be that string that it returns. Now, if n turns out to be really large and we run it on a really large file, right? If I say the chunk size should be 1,000,000, and I've got a terabyte file, terabyte-sized file, bad news for everyone. But assuming that we have a normal size file and that our n is normal sized as well, we should be just fine.